All right, so y'all go ahead and do the factoring of the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video, and I'll go over the correct answers. So for the factoring, you're going to want to do remove, replace, reduce. So you're going to multiply the 4 by the 9 to remove that 4 and make it x squared minus 12x plus 36. Then you're going to factor that, and that's going to make x minus 6 times x minus 6. Then you want to replace the number you removed at the beginning, which is the 4. And then you want to reduce them. 4 and 6 both divide by 2, so that's going to become 2x minus 3. And then the same thing on this one, 2x minus 3. And so if you want to leave your answer like this, you can. Or if you would rather make it 2x minus 3 squared. Either one of those is fine with me. For the math knowledge question, it refers to the year 1776 as 7 years ago, which gives what a score would refer to, which is S. So they all have 4S plus 7. And the difference between these 2 years is going to be what 4 scores and 7 years ago is. So 1863 minus 1776, which is A. So that would be your answer. Okay, so we are looking at lesson 20 today. We're going to look at change of base and graphing origin-centered conics on a graphing calculator. You should have studied change of base last year in pre-calculus, so hopefully that'll be review. And then the graphing calculator part will be new. So y'all do need to get a graphing calculator for that. All right, so we want to change this so that we can actually figure it out using a calculator. Right now, our calculator we only can use when it's a log base 10. So this one we can't plug into the calculator because it's a log base 4. But if we use change of base, that'll make it so that we can put it into the calculator. So the first thing you want to do is to put it in exponential form. So putting it in exponential form would make it 15 equals 4 to the y. And then we're going to take the log of both sides, just like we did in lesson maybe 18 or 17, just a couple, lesson 16, a couple of lessons back. So now that we have a log on both sides, we need to move the y to the front. And then how can we solve for y? All you have to do is divide by log base 4. And that's what y equals here. And so that's your change of base. We've changed it to a base of 10 now. That's log base 10 of 15 over log base 10 of 4. Do you see a shortcut? So again, I'll write our answer. Log base 10 of 15 over log base 10 of 4. Anybody notice a shortcut? You're going to do the log of this argument over the log of the base. That is the shortcut. So log of the argument over the log of base. So you don't have to work it out every time. You just use the shortcut. There's no point in working it out unless you've forgotten what it is. So if you forget it, you can work it out, but otherwise you can just use the shortcut. So we want to rewrite log base 4 of x using common logs. So your common logs are the log. Natural logs are the ln. So we want to use change of base to rewrite this. So we're going to do the log of the argument, which is x, over the log of the base, which is 4. And so that would be your answer. We don't need to solve it for anything because it just said to rewrite it. Okay, looking at this one, we want to estimate it using a calculator. So again, we can't plug it in as it is right now because it's not a log base 10. So we change it by writing
log of the argument, so log of 67, over log of the base, log of 4. And so if you use your graphing calculator, you're going to do log of 67. Make sure you close your parentheses on these. Otherwise, it's going to mess it up. And then divided by log of 4. And you should get 3.0330. So that is your answer. Okay. We're going to use a calculator to approximate this one. So we need to rewrite this log base 15 of 6 and this log base 4 of 7. So we're going to rewrite them as log of 6 divided by log of 15. And then log of 7 over log of 4. Okay, so that's the first thing you need to do. Now we need to get decimals for these two numbers. So if you use your graphing calculator, you can actually do all of that in one line, but I'm going to break it up just so that you can see a little bit more clearly what you're doing. So you do log of 6 over log of 15, and then you do log of 7 over log of 4, and then we're going to do 4 times that first number plus 5 times that second number that we got. Oops, I forgot to put the times. So 5 times that second number. So you should get 9.6650 is what it would round to. Now I'll show you how you can do it all in one line. You can just do 4 log of 6 divided by log of 15 plus 5 log of 7 divided by log of 4. And you still get the exact same answer. So 9.6650 either way. For your answer. So that's how those work. I personally just plug it all in at once, but if you have trouble with making sure your parentheses are right and everything, then you don't want to do it that way. You want to just break it down and plug it in separately. Okay, so now we're going to find out what B is. I'm trying to find our base. So the first thing we want to do is to put it into exponential form. We're not going to want to use change of base on this one because B isn't over here. It's going to be, if we had put it in change of base form, it would be this, which still doesn't help us because B is not by itself. So we're going to say 47 equals B to the 17. And then the way that we change it so that B is by itself is to take the 17th root of B. So we're going to also take the 17th root of 47. And so B is going to equal the 17th root of 47. And so if you use your graphing calculator, you're going to go to math. And you see number 5 where it's the X root? That's the button we're going to use. But if you hit it, this is what comes up. Sometimes it has answer, and then it'll come up with the little root thing. So if it does that, then you need to hit the 17 first. So let's see. I'll see how it went ahead and put the 17 in there. So if yours comes up as answer, then you want to put the 17 or whatever number in first before you go to that little button. And then our number that's in the radical is 47. And so I get 1.2542. And so that would be your answer for B.
Okay, so now we're going to look at graphing origin-centered conics on a graphing calculator. So we want to graph this on a calculator. And we've been graphing on our graphing calculator pretty much all year. If you look, we've been going to y equals. And if you look at it, it has y equals, and you have to plug it in. So we should know what this graphs. X squared plus y squared equals 4 is going to graph a circle. And its radius is going to be 2. That's what we should have as our graph. So we have to solve our equation for y so that we can plug it on into the graphing calculator. So y squared would equal 4 minus x squared, and then you would take the square root. And when you take the square root, what do you have to remember to put in front of it? A plus or a minus, hopefully is what you said. So we have plus or minus the square root of 4 minus x squared. So if you wanted to graph that on the calculator, you would do the square root, square root of 4 minus x squared. And if you graph that, what is my window? My window's really large. You graph it, it gives you the top part of the circle. Why don't we have the whole circle? Because over here it says plus or minus. So you need to go back over here and you need to do the negative of the square root of 4 minus x squared. And then if you graph it, it makes the whole circle. It doesn't look like a circle, and that's because this is a rectangle, and so it's not exactly to scale. You'll see how the x tick marks are wider, further apart than the y tick marks. So if you want it to look like a circle, you need to go to 5, which is zoom square, z square, and that'll make it look like a circle. So if you're concerned about that, that's how you fix it. Okay, so let's look, whoops, at this example. We want to use a graphing calculator to graph the curve given by x squared over 4 plus y squared over 9. So we have to solve it for y. And so on this one, what I do is get rid of the fractions first. You don't have to, but I like to get rid of my fractions first. So multiply everything by 36. So that's going to become 9x squared plus 4y squared equals 36. So 4y squared equals 36 minus 9x squared. And then divide by 4. And so you can write it all over 4, or you can make 2 separate fractions. Either one is fine with me. And then from there, y squared will equal, you can either leave it as this whole one fraction or make it 9 minus 9x squared over 4. Either one will work. And then you take the square root, and we have to put what in front of our radical? Plus or minus. And so 9 minus 9x squared over 4. And so that's what you're going to be plugging into your graphing calculator. And so we go back to y equals, and we're going to do the square root of 9 minus 9x squared divided by 4. And then we're going to do negative square root of, and I'm going to do it as one fraction just so you can see what it would look like. So you would need to do open parentheses 36 minus 9x squared, close parentheses, and divide by 4. So either way will work. And then you go and graph it. I don't know why it keeps, there it goes. And so there's the graph. So I'm going to zoom in a little bit. And this is not a circle. What is this a graph of? An ellipse, hopefully, is what you're thinking of. It's an ellipse where you go left and right 2, because that's under the x. So we went left 2, right 2, and then you go up and down 3, because that's the square root of 9. So we went up 3 and down 3. If you notice, Do you see how it doesn't actually connect to the x-axis? Like it leaves a little gap? That's okay. The calculator is pixelated and it just can't graph it exactly like it needs to. So don't worry about if you have this on your graph. It doesn't mean you graphed it wrong. On your test, you're not going to bring your calculator up to me to show me, here's my graph. What it's going to ask you for are the equations that you would graph. Like, what equations would you use to graph this curve on the graphing calculator? And so you would be looking at these equations down here. So that's what it would be asking, not actually to plug it into your graphing calculator. Okay, so hopefully that helps you with lesson 20. You do get to omit number 22 on your homework, so make sure to do the other ones so that we can go over any questions you have tomorrow.